Lesson 47, Basic File Input and Output. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. In this lesson, we demonstrate how to take input from and send output to a file. The subject of file I/O runs deep, but we are going to limit ourselves to what we need for now and put off the rest until later. File I/O is performed via file streams, which function almost exactly like our console streams cin and cout. For our first program, we will demonstrate how to read from a file. To begin, we use Notepad to create a simple text file with this text in it. Note that our project is called test2, and we have saved the text file in the same folder where our project is. At the top of our code, we include the file fstream. This allows us to use file streams. We also include the file string because we will use STL strings to receive input and output. Our main function begins with a declaration of the ifstream object. The I stands for input, since this is an input file stream. An input file is a file that we can read from, just as we do for cin. The constructor takes the name of the file and opens it for input. Then we declare a string that we will use to read data into. We read in a line of text at a time, so we have named our string line. Next, we have a while loop that reads in data until we hit the end of the file. Inside the loop, we call getLine with the file and string as arguments in order to read the next line of file into the string. Then we output the string to the console window so that we can see what is read. Finally, we close the file when we are done reading from it. Executing the program, we see the contents of our file outputted in the console window. Instead of reading in entire lines, we can read in one string at a time. To do this, we change the call to getLine to a call to the extraction operator. We should mention that the characters of a string are read until we reach a whitespace character like a space, tab, or endline. So if we execute the program now, we see the lines broken into individual strings. In our next program, we demonstrate how to write to a file. We begin by declaring an OF stream. The O stands for output, so this is an output file stream. Notice that we use the same file name as before. Then we declare two strings which contain a quote from Ayn Rand's novel Atlas Shrugged. Below this, we use the insertion operator to send these strings to the file. Again, we close the file when we are done. Executing the program doesn't display any output. However, our file has been changed from this to this. In other words, our output wrote over the text that we had in our file. If we don't want the contents of our file destroyed, we can open the file in append mode. In this program, we add a second argument to our constructor to tell the stream to write at the end of the file. Now we have another quote from Atlas Shrugged, which we send to the file with these lines. Executing the program, our file is changed from this to this, and our first quote is in the file along with the second. Up to this point, we have been cavalier in assuming that our file would open correctly. In practice, a file stream can fail to open for several reasons. The most common reason is that the file name is incorrect. In this program, we illustrate what happens when a file fails to open and how to check for it. So far, we have assumed that our file was located in our project's directory. However, we would like to be able to access files that are anywhere. To do that, we can use the full path name. The full path name for the file that we have been using is this. Now we put the full path into the constructor. Next, we check whether the file was successfully opened and output the contents if it was successful. Of course, we already told you that we were going to show what happens when it fails, and that's exactly what happens when we execute this code. Our if statement outputs a message to tell us that the file didn't get opened, and returns 1 to indicate an error. Without this, the program fails silently, and we might wonder what happened. So why did the program fail? The problem is that the backslash character is used as an escape character. That is, we use it with an n, for example, to put an endline character inside of a string literal, or we use it with quotes to put quotes inside of a string literal. A full table of escape sequences can be found on our website at this URL. In order to put a backslash in a string literal, we need to double it like this. Now if we execute this program, we see all of our strings outputted. Notice that none of the white space is shown. As we said before, whitespace signals the end of input, and none of it goes into the strings that we read in. This concludes the lesson.